Okay, then for any string, we know that processing starts in the initial state. Okay, now and it ends in final state. Now if the length of the string, if it is greater than number of states, then obviously there will be the some sort of loop in the processing of string, right? So let's consider here the one intermediate state qj, where the loop starts. Okay, where the loop starts, maybe it a self loop on a one state, maybe a direct or indirect loop, maybe there are the intermediate states again here. Okay, but if there are length of the string is more and number of states are less, then obviously it will perform some sort of a repetitions or loop somewhere in the processing. So consider this as a loop part. Okay, now this is from starting to the, from initial state to the start of loop. Let us assume this part, this part as a u part. Okay, this as a u part, this loop, let us consider this as a v part. Okay, and then from loop plus 1, let us consider here w part. Okay, so this way we will divide the given string u v w into 3 part, from initial to the start of loop, then loop, and later on the after loop up to the end of the string, that is final state. Okay, so this will accept here the first character starts, then here consider that before the start a of j plus j minus 1 is there. So we consider here a of, sorry, I consider here I, not j. Okay, a of I. Okay, then from, then whatever the characters are there from a of I plus 1 to a of j. Okay, so a of j will be the last character of this loop, and then here starting will be a of j plus 1 up to length of the string we have taken here a of m. Okay, so here u is a starting part, u is a starting part, then v is a cycle part, v is a cycle part, and w is remaining part. It is optional one, it may exist or may not be, but there must be the some characters in the cycle part, that is nothing but the v part. Okay, now divide the string in the 3 parts. Now this way we will divide the string, divide the string in 3 parts. Okay, so here we have divided the string into u v w. Let's see again in diagram, from initial to the before the start of the loop, it will scan the u, a of I, a1 to a of I character it will read, then remaining characters a of I plus 1 to a of j. Okay, the loop will be there, then a of j plus 1 to the last character of the string, it will be the w part. Okay, so if we write x is equal to u v w, then we know that the what string is a1 a2 up to am. Okay, then we will get here the length of the string u as substring u as a1 a2 up to ai, this ai character. Then next character means v part, a of I plus 1 to a of j, that is cycle part, and then next character a of j plus 1 to to a of m, last character of the string. It will be the w. Okay, now the last step is, now here we divided the string into three part u v w such a way that, okay, now if we pump means insert, if we pump v cycle part, many, now cycle means we can use that for n number of times, v for many times, then we will get the new string definitely. Then the new string we get is u v raised to power I w, where I is greater than 0. Okay, and if new string u v raised to power I w, if u v raised to power I w, if it is belongs to L, then L is said to be regular language. Otherwise L is not a regular language, such that 1 is less than or equal to mod of v less than or equal to n, and I is greater than or equal to 0. So this is about the pumping lemma theorem and its proof. Okay, so let's see again here. First write down the statement, then this is the complete statement, then consider the language L, then consider the finite automata M, where L is equal to L of M, language accepted by given finite automata. Finite automata has the n number of states. Then consider the string, any string, suppose it has the length, it contains the character a1, a2, a3 up to am. The length of the string must be greater than or equal to number of states. Then we know the processing of strings starts in initial state and ends in final state. Now in graphical representation we can show this one, q0 to qj first part, then qj self loop will be there, and from remaining part will be accepts from qj to final state. Okay, so characters of a string a1 to ai for u, ai plus 1 to the aj up to aj loop cycle, and the a of j plus 1 to a of m is nothing but the qf. So mention in this one uvw. Now just if we pump this middle part for n number of times, many times, we will get the new string, and all the new strings must be, if all the new strings belongs to L, then we say that the language is regular, otherwise. So this way pumping lemma theorem recognizes whether the given language is regular or not. So this is the useful for recognizing language. Okay, thank you all. We will see in next video the few examples on this topic.